Okay, here it is. Condensing oh yeah. Condensing logarithms. What is this word to condense, right? The root word is to condense. And that means, and it's applicable here, condense means to do what? To make smaller or bring together is one. Make smaller, I like that, thank you. Make smaller, that's one interpretation of it because it depends in what context you're using the word condense. Make smaller, what's another thing I wanted to say? Bring together is one. Bring together is one. It's just kind of like what we're doing here. Bring together as one. To condense or condensing these logarithms. So they're going to be expanded, right? It's the opposite of expand. Condense. Okay, let's just jump in here. Here's what it says. It's going to say condense each expression. Here's the directions. Condense each expression to a single logarithm. Oh, it's already telling you. So up until now, we've been expanding. We've taken one logarithm and expanded it into these different parts. Now we're going backwards. Okay, so let's jump in. Number 1. 2 log 3 7 plus 4 log 3 8. Okay, so just keep this in mind. Remember this. We only want like addition. Eventually we're going to only want addition and exponents. Yeah? Well, this one's a really simple one, so we're not seeing it here, but remember, anytime you have any number here in front, what happens to it? We're going backwards now. What happens to this number? If it got dropped down, wasn't that the exponent, right, going backwards? So now, this is going to be log 3 of what? 7 what? Squared, right? You're bringing this number up. Right, this 2 that was here, you're bringing it up. And then it's going to be plus what? And there used to be a 4 right here. It used to be 4 log 3 8 like that. I don't know if you can see my little... It used to be a little 4 right there, but then that 4 is going to come up to, you guys agree? Yeah, we're going backwards. Before we used to have those exponents, drop them down. Now any number here comes back up as an exponent. And then, so now we just got what? Log 3 7 squared plus log 3 of what? 8 to the power of 4, yep. And now anything that's plus is coming together as a single logarithm, so we only write it once. Log 3. And these have to do what? Remember, we're going backwards. If it's a sum, it comes back together as a product. Remember, expanding the product breaks out into a sum. And these numbers are really big. You don't have to multiply them. Sometimes when they're smaller, they'll put an answer. They'll actually multiply it. And I've seen in the worksheet they leave it like this. They'll write the answer like this. They'll use parentheses. You don't need it, but I'm just telling you what you're going to see when you. I mean, it looks more complicated when they have parentheses, but you really don't need them. Adrian, you sit over there. Where did you sit last semester? Third table. The chair not next to the window. Adrian Hernandez, right? Okay. Yeah, right behind Quincy. What do you guys think? It's the same, right? We're just going backwards now, so it's like you gotta think backwards. Okay, that was number 1. Let's go to number 2. We're good? No questions? All right, number 2. So that's what I'm talking about. It's like nothing new, but it's going backwards, so it's a little trickier. Let's go faster now. Log 511 plus log 5/8 plus log log 5x over 2. Oh yeah. Oh shoot, you can't see that. Sorry. Okay, I have no numbers to move up here. These are pretty clean. There's nothing happening with these first two. But I got to fix this. There's something up with this. Anybody can tell me how I'm going to look at this? Isn't this really going to be plus? What does it mean when it has that 2 right there? Isn't that really a 1/2? We got to see that it's a 1/2, yeah? So it's really a 1/2 log 5x. And then when this 1/2 goes up to a power, isn't that going to have to come up? Isn't it really going to be log 5? Well, it's going to be x to the power of 1/2, isn't it? It's going to be x to the power of 1/2. But remember, when you have fraction, it's a radical. It's going to be what? The square root of x. Am I going too fast? It's good, right? So that's how you're going to deal with when you have these numbers in the bottom. You got to see the fraction. Pull it out to the front, take it up to the top as an exponent, and then it's going to be a radical. It's going to be, in this case, a square root. Let's bring the rest of these down. So you guys agree log 511 plus log 5/8 plus this. Oh, wait a minute. Wait. Oh, no, that's right. And when I now bring this all together, right, these don't have powers. When I bring all this together, isn't it going to be, right, to a single logarithm? We're condensing it and bringing it down to a single logarithm. Isn't it going to be log 5? And isn't it going to be 11 times 8 times root x, like that? Yeah. Sometimes they'll leave it like that, and again, sometimes if the numbers are small enough, they'll multiply it. They'll actually multiply it. This is an acceptable answer, but if the numbers are small enough, sometimes they'll multiply it, so that it'll be log 5 of what? You guys agree? 88 times root x. And again, they might make it look a little trickier or whatever, more difficult if they put the parentheses or write it like this. But you guys know that all that means the same, right? Yeah. Okay, good. Ready for 3? Because we're building up to, these starting with the easy ones and building up to the more challenging ones. Okay, so something you don't catch right now in the notes during class, then remember, this is going to be recorded. It's going to be in the video. You guys can go back, watch it, and fill in or listen in again. Okay, number 3. Number 3 is going to be 4 log 9/3 minus log 9/5. Okay. Anybody remember this? What's going to happen here? Well, this number is going to go up, right? So it's going to be log 9/3 to the 4 and minus what? Log 9, 5. And then remember, a subtraction is really a what? A division, right? A division. So now bringing it together as a single logarithm, that's going to be log 9 of, remember a division is this one? So it's going to be what? 3 to the power of 4 over what? And this part's the bottom part. Just 5, no? And I'm looking at the answer sheet. They actually just left it like that. They left it 3 to the 4 over 5. If you put 81 over 5, you can do that, right? 3 to the power of 4 is 81. And sometimes these numbers will be divisible. This one's not. 81, not evenly. 81 does not divide by 5, but either of these two are acceptable, okay? If you look at the worksheet, they have it like this. Okay, number 4. Next one. Okay. Number 4. Let's do another easy one real quick. Okay, another subtraction. I know what subtraction is. Bring the powers up. I mean, not the powers, but these numbers in front. Bring them up to a power, right? Going backwards. So that's going to be log 3, what? X to the power of 6 minus log 3 y to the what? 12, right? Yeah? Yeah. And then once you have two of them and it's subtraction, this is the division one. Right, bring it together as a single. That'll be log 3 of the first one divided by the second one. So x6 over. Yeah? Yeah. All right, I think we're ready for the tough ones. We're good? You're seeing how this has to go? Okay, number 5, here we go. Now the tough ones are going to start, a couple more. So I don't want you to say, yeah, you just do all the easy ones in the notes and then the assignment's all hard. Okay, 5. Okay, then here we go. You want something like this? Here it goes. Oh, yeah. This is a W, this is a single U, or just a U, and this is a Z. And this is a number 2, and this is a number 2. All right, what do you think? What should I do first? I don't want to see this. I don't like it. So it's going to be log 6W. I know you know in your head, but believe me, see it. You guys agree that 2 is really a 1/2? Log 6u, and that also is also a what? Oh, a 1/2. Oops, 1/2. Like this one, 1/2. Log 6z. Then what? Then we know these 1/2s are going to come up, so it's going to be u to the 1/2, and that's going to be z to the 1/2. But that's going to be a square root. Do you guys agree it's going to be square root? Yeah. So now I'm going to write it like this. Log 6w plus what? Log 6 what? Root u? Root u. Square root of u? Is that right? Did I jump too much? You guys caught that? We're good? We're good with that 1/2 exponent is a square root, right? Yeah? Plus what? Log 6 what? Z to the 1/2 is square root of z, yeah? Yeah. Okay, now what? Now we got everything what? Plus. What does everything plus mean? Oh, that's multiply. Remember that? Multiply plus comes together, condenses it into a single logarithm. Is going to be a product. Multiply. So that's going to be log 6 of what? Well, w times what? The square root of u times the square root of z. Is that right? We're good? Is that the final answer? No. These can multiply. These that are under the same square root can multiply. So you're actually going to get log 6w. And when you put these together and these multiply, because it's the same root, it's a square root of what? uz. So this is correct. That's the final condensed form. And again, the book or the answer sheet will have what? They'll put parentheses like this, but you know, it's the same deal, right? Same deal. Questions? We're good? Okay, 6. All right. What about that? Oh, you know what? Let me add something here just to make it interesting. Just to make it interesting. What if I put a 2 right here? Oh, yeah. Oh, shoot. No. Yeah, you know what? Let me just put it there. Okay, go ahead. Leave it like that. Well, do you agree this is 1/3, right? That divided by 3 is really, you pull out that 1/3 log 2a. Yeah. And this is also going to be what? Another 1/3 right there? Yeah? Log what? 2b. You guys agree? And don't tell me you're going to get stuck here. What's going to happen here? Another 1/3, right? So it's another 1/3. 1/3 log 2, but this is c squared. Okay. And do you guys agree this is going to come up to a power? So that'll be a to the power 1/3. All right, let me just write it. Plus what? Log 2b to the 1/3 power. Yeah? Plus log 2c squared. But what happens if you have that and then it's raised to the 1/3? Remember that business? We did that? You guys remember that? This is a 1/3. This is a 1/3. What's this? I mean, these are ready to go. I know these are cube roots, but this one I gotta clean something up. What's this gonna be really? Log 2. It's gonna be the cube root of what? C squared, right? The 1/3 is the cube root, just like these are gonna be what? Log 2. Isn't that the cube root of a? Isn't this 1/3 a cube root, the fraction? Yeah. Plus log 2 what? Cubed root of b, yeah? Plus, and then see, that's the cubed root. Leave that there. That's just going to be the number. That's just going to go inside. Yeah? That's it. We put everything together. Everything's plus, so everything's multiply. Bringing it together as a single logarithm is going to be just a log 2 what? Well, I got the cubed root of a times, then I got a cubed root of b, and then I got times what? A cubed root of what? C squared. Is that the final answer like that? No. If it's under the same cubed root, you can put it all together and just multiply those parts inside. So it's going to be what? Log 2 cubed root of what? A times B times what? C squared. Does that make sense? All right, so that's it.